Good. Okay. So here we go. Okay. So today's lecture, ladies and gentlemen, is on the issue of estimation. We'll define estimation in this, for the sake of this lecture, as sort of an honest, realistic assessment of how much resources. Typically, time is the most obvious one in software. The software management side that comes to mind, but also dollars or human resources are required to secure certain objectives that are defined for your project. How long will this take, for example? And where this is often a bigger task that has to be undertaken. Maybe it's implementation of some feature associated with your system. Now, I wanted to give you a couple broad take-home messages from this, because we're going to be hitting on a lot of specifics for this lecture. And it's easy to kind of lose track of the forest for the trees. There's a couple overall themes that come out of this lecture, and these themes are the sort of things that are ripe for quizzing and for examining. So I want to emphasize these up front. The first of them is we're dangerously poor at estimation. People, software developers, tend to have very poor capacity to estimate closely how long certain tasks will take. What's worse is we're not only inaccurate, we're inaccurate in ways that put ourselves systematically at disadvantage, at worse disadvantage. We're inaccurate in a way that is worse. Instead of overestimating, which has some costs associated with it, but which is not nearly as damaging, we tend to underestimate how long things take. And that leads to a gap between, it sets expectations in a dangerous way on the part of the stakeholder, because they expect the deliverable sooner, and we actually give it to them later. It can lead to disappointment in a way that overestimating how long it would take would not. So we tend to be poor at estimation. There's often a conflation, particularly on management side, the management of software projects, between targets and estimates, or guesses and estimates. And there's often a lot of managerial pressure applied to turn what would be an estimate into just a target, or vice versa, I guess it's a better way to put it. Take something which they want as when you'll finish it by, and that you'll somehow choose that as your estimate of how long it will actually take, which is very dangerous. Having something imposed on you saying you need to finish this by December because we need it by then, and to treat that as if it's an estimate of how long it will take is often really misleading and sets yourself up for a disappointment, sets yourself up for a failure to deliver on time. If you look at the top risks associated with software development, late delivery of projects and projects that are over budget are two of the main ones. And a lot of those problems are not just problems about coordination and delivery of the project, so there's plenty of that. There's plenty of projects that go bad in a systemic way, and we'll talk about why that is later in the term, in ways that cascade. There are feedbacks that lead to projects going astray. But a lot of that gap, a lot of the reasons these projects are late is because of the yardstick that's used to judge whether they're late. And guess where that yardstick comes from? Often it comes from managerially imposed targets. They say, I want this by then, and you're going to give it to me by then, and that estimate doesn't come from your team, your technical team. It comes from above. It's imposed upon you, and then you fail to deliver, and it's judged as a failure of your project. Well, guess what? That's not a failure truly of your project, but it's counted as such in the statistics. It's actually a failure of management. And learning to kind of push back against that sort of shenanigan is one of the issues that comes to the fore in dealing with estimates. So estimates should be made by the technical team. They should not be the province of pressure from management, particularly pressure to set the estimates optimistically. Now, one of the best ways we can sidestep a lot of that pressure, sidestep a lot of the dangers associated with over-optimism, is what are called range estimates. So these are estimates that are not point estimates. In other words, they're not specific single numbers that specify how long it will take to deliver on a given task, but rather it gives a range. And what do you think that range represents? Why would you give a range? Why is there an upper bound and a lower bound that are different?
One number is very, very, very unlikely that's going to be exactly that one number.
Good. So it's very unlikely to be exactly that. And what is the width of that range associated with? Yeah, it's error bounds. It's associated with confidence intervals. It's associated with uncertainty. Uncertainty about how long this thing is going to take. Risks often associated with it. And often those are the things which lay hidden and unexpressed to the management if you just give a single number. It doesn't express, okay, maybe I have the same mean estimate. This thing is going to take me 2 months to deliver. But in one case, I have a big uncertainty about it. In the other case, it's a very straightforward thing. It's something I've done many times before, and I can estimate with great confidence how long it's going to take. If you just give a point estimate, those two can't be distinguished. You just say 2 months. It's going to take me 2 months to deliver on this, and it's not clear how wide that error bar is. It's not clear how wide that confidence interval is. It's not clear how wide that credibility interval is if you treat it from a Bayesian perspective. So here, range estimates are a way of providing information to those who are seeking these estimates that there's quite a degree of uncertainty here, there's less uncertainty. And that can be very valuable for that. They can also avoid the situation where you're pilloried, you're pegged for having missed this single point estimate. Instead, you're trying to fall within this range. So they're very, very attractive ways of estimating things. And in my own professional consulting work, I've used those to very good effect. And I'll tell you that it helps the team that's employed me much better plan about how long things would take compared to the mean estimate that I would have given. And it helps me reflect the risks, the unknown risks, or the risks of associated with unknowns that need to be addressed. Now, the final point here is something that is sort of a point of wisdom in terms of a best practice that's built up within the software industry, and it relates to something Connor mentioned earlier, which is when we're trying to estimate things, and we have multiple estimates, perhaps from different people, perhaps for different sub-pieces of this thing. Often we'll get errors in those estimates that cancel once we aggregate them up. Sometimes the error on one side or the other, and they'll cancel out. So the point of advice here, and this is a point you'll see reflected in the practices of companies in the software industry, is to estimate a task, you break it down into its pieces. Don't estimate as a whole. Think in very concrete terms about what it takes to deliver on this task in a step-by-step fashion, and reason about estimating those things. And it turns out you can often do a much, much better job once you do that. Once you're reasoning about the detailed pieces compared to just estimating the whole thing. The whole thing, it's very easy to fool yourself. In general, you're thinking about some big, vague sort of notion. It's easy to pull a number out of a hat, or worse. And if you break it down into pieces, you're forced to kind of think about, in very concrete terms, how those relate to things you've done in the past, how they relate to cases where there have been unexpected barriers, or where you've had to deliver on similar items, and it gives you some basis for giving the number in a way that the task as a whole does not, because often the task is new. You've never encountered it before. So here we're going to reason about its pieces. We're going to take it, we're going to decompose it into pieces. So these are some key take-home principles associated with estimation. Okay? And these are eminently examinable. So we're going to expand on these and, as time allows, go into considerable detail. So you'll recall this estimation quiz. And this is a graph from the author of the book from whom this is derived, Steve McConnell, in his book Software Estimation, which shows historical performance across the various workshops he runs and how many people, how many correct answers they had. This is a histogram for different people, what fraction of those people, say 6% for 0, had 0 correct. What fraction had 1 correct? In this case, it's about 18%. What fraction had 2%? That's the largest amount, with about 24%. So you remember I asked you to find to be confident about what fraction of the time should it have fallen, should the true answer have fallen within, should your answer have fallen within the bounds, excuse me. What fraction of time should the true answer have fallen within your bounds? 95%. So what you'll see here is that, like was the case with the class, well, what? Can you summarize? What does this graph tell us? Underestimating what? Okay. Underestimating our confidence? We're overestimating our ability to bound, certainly, these numbers. We're overly confident about our answers in the sense that we have narrower bounds than we should. We're saying we're establishing bounds that are not 95% confidence intervals. They're more like 20 or 25% confidence intervals. 25% of the time or 20% of the time it falls within those bounds. So we're overly confident about the accuracy of our answer. And this is a common feature within software. So what is estimation? Why do we do it? Well, fact is, whether it's for a small deliverable for a given deliverable of an agile process that might take 2 weeks to deliver, or whether it's a larger task associated with rollout of new version of software every few months, we often need estimates to kind of figure out which features go in there. So for scoping decisions, do we put this feature in or not? How long would it take us to implement is a common question. If it's going to take too long, we leave it for a later deliverable, or we break it into pieces and only do part of it. Another reason we do this is to assess the level of risk involved in a project. If there's if there's something that may end up taking a long time, it could take a long time or it could take a short amount of time. It's an indication that there's risk, and taking that into account may involve extra considerations, such as shifting the risk, getting some sort of spike prototype in place, or otherwise sort of choosing carefully what we promise. And finally, sort of planning stage deliverables associated with successive deliveries, what thing goes in which one. So I talked earlier about a definition of an estimate, and I want to distinguish that from a target. A target is an aspirational goal. It's something for which you shoot. Okay, we're going to shoot for this. We're going to see if we can get this implemented within the first week of the 2-week cycle. It's not necessarily based on a belief that it's possible and that it's likely to take that long, but we're going to try to motivate people to kind of work towards this. And sometimes this is given, sometimes it's chosen, sometimes it's imposed on you, but it's a quite different thing from an estimate. We're going to shoot to get it done by then is often quite different from the sort of estimate you'd have if you sat down and figured out realistically how long do we think this is going to take. It's kind of it's a way of motivating people to shoot for something high. You shoot for a high bar, and sometimes it takes a lot longer than that. Targets are things that management often wants you to adhere to. So they would like you to try to get this done by a certain time, but it's not something which comes from a sober, careful retrospective on the work that has to be done and an estimate of how long that will take. I'll also distinguish this from a plan, which is a specific recipe on how we're going to achieve this objective. What are the steps by which we will build it up? Some reasoning about the plan might be involved in giving a good estimate, but the plan itself involves lots of pieces about the exact staging of how you're going to go about this, perhaps aspects of testing, quality assurance, peer reviews, and inspections, etc., that are outside the scope of estimation per se. Okay, so a couple key considerations that I touched on before. So estimates have a strong optimistic bias, and often early estimates in a project are used to judge the success of that project. I mentioned this earlier. When we have projects we're going to undertake, those projects are judged against a yardstick of success defined by early estimates or early indications of how long they'll take. And again, you could have a project that's highly, that the same project, and an estimate was given early that it would take a long time, and it's judged a success because it delivers early. Or you have the same project, same deliverables, same outcome in terms of quality and scope and dollars, but the early estimate was that it would be finished quickly, and it's judged a failure, or it's judged a problem as a project. So you have to be careful about the estimates you give, because not only because they can be wrong, but because they are used to judge whether this was a successful enterprise. And as such, they have a special weight. They have a special gravity associated with them. And a very important issue is by whom this estimation is conducted. And so a couple principles here. Don't allow targets to become estimates. Don't allow these sort of aspirational goals to become when you will deliver it, right? And also don't engage in this sort of placating behavior. We'll say, well, okay, you really need it by then. Okay, I'm sure we'll be able to do it. And then you find you're not able to do it. I don't know how many projects have foundered on this reef of not being able to say no to the stakeholder in terms of unrealistic expectations. But it is a dangerous reef indeed. It is a shoal of many woes. And there's some very interesting writing about pathologies that occur in the context of projects in terms of blaming and placating as kind of two anti-patterns within projects, where project management is unable to say no to management, or in other cases where it turns into a blame game. And this is one of the big pathologies, is where they accept estimates that are too low, they cross their fingers and hope, and it doesn't have a chance in hell of being delivered in time, and then the team gets blamed for it. The technical folks who have really little to blame. Unfortunately, this has happened in too many projects. So try to avoid letting estimates be turned into commitments here. An estimate, when it is made technically on a grounded basis, it can be helpful for planning, but it should not be a commitment that, yes, come hell or high water, we are going to deliver this in this time. It may be a very educated guesstimate of how long it's going to take, but as far as a commitment that we will deliver it in this time, it's dangerous to adhere to that sort of level of responsibility. So the writer Tom DeMarco, who has a number of great books, including Waltzing with Bears, one on Slack, and other common projects. He's also the creator of the book that I recommended on sort of softer side of project management. He comments in one of his books, I think this is in Peopleware, A common definition of no, it's in software estimation. Excuse me. Oh, this is by McConnell. I thought it was this is quoted from Tom DeMarco by McConnell. Common definition of estimate is the most optimistic prediction that is a non-zero probability of becoming true. This is unfortunately what a lot of people in software adhere to. You take out your finger, you hold it to the wind, you say, how quickly can we do this? And you give an optimistic estimate because you think there's some chance we can deliver this in time. And as Tom DeMarco comments, accepting this definition leads irrevocably towards a method called what's the earliest date by which you can't prove you won't be finished type of estimating. It's really dangerous. You're giving this estimate which is optimistic, and it's the kind of first estimate where you think you have a decent chance at delivering. And believe me, that estimate will then set the yardstick for judging if it's been successful or not. So the three big dangers here, there's three kind of distinctive dangers, each associated with estimates. One is that putting aside people's judgment of how long things will take, if you actually look at the distribution of times associated with projects, what you will find is that if you think about projects that might be designed to be delivered within a 3-month time, what you tend to find is there's long tails. It's a skewed distribution. Things can take a lot longer than you would think, but they can't take a lot shorter. Among other things, the project can't finish earlier than it started, right? So there's an asymmetric distribution associated with project delivery times. Okay, project length is skewed in a positive direction. Some projects take a very long time, some take very little. So that's one issue we have to take into account. Some things can take very, very long time, but it's hard to be that much. There's a lower bound on how long it can take. There's no upper bound on how long it can take within sort of realistic limits. Secondly, there's psychological tendencies. We tend to estimate things on the side of being overly optimistic. We tend to give estimates that are too optimistic. The third thing is there's asymmetric risk. So if you underestimate how long it's going to take, it's often a lot worse than overestimating by the same amount. Why is that? Why is that?
It's safer for your plan if you're waiting on something to, if it's finished early.
Yeah.
And if you're waiting on it, because if it's on the critical path for something else.
Okay.
Then you just held back the whole project.
Okay, so I think there's some good elements of that. So suppose this project is going to take, you estimate this project is going to take 6 months to complete. And it actually takes 7 versus it actually takes 5. Which of those is worse, do you think? Why? Give me a concrete thing that might happen. If you underestimate, what bad things might happen if it's 7 months instead of 6? You had some good components in your answer.
Oh, I mean, if it's part of a larger project.
Yeah.
If it's part of a larger project, then you're going to be
good.
Holding back other stuff potentially.
Okay, so maybe this project is all about getting the software ready for the Olympic Village associated with an Olympics. And the Olympics is in 6 months' time, and you have to deliver. If you come in 5 months, that's maybe a bit inconvenient in the sense that, okay, now they have to pay out money to you sooner. Okay, so that's fine. But you think they'll be really disappointed if it comes in 5 months? How about 7 months? Okay, in some cases it's a good thing. Not always. In some cases it can be like, oh, okay, now we got to find things for you to do for the next month. But in some cases it can be good. How if you come in 7 months, the Olympics in 6 months? The Olympics are over, sorry. Your software is now useless, right? And that's an extreme case. But there's many other cases like that. You shoot for holiday season for certain deliveries of software or hardware. You aim at, maybe you're working for a bank, software for a bank, and that bank's going to merge with another bank, and you need to have the software in place that will work with that other bank's system in time for them to do a switchover. So they're planning all these processes associated with switchover in December of this year. And you estimate that you'll be done by November. And it turns out that you finish in October. Is that bad or good? Well, it's good, yeah. You have more time for testing, maybe. They have more time for sort of rehearsing things. How if you finish in January? And they basically allotted already December for the whole switchover process. Now you've followed up their schedule. Now suddenly their January is devoted to other things. Maybe it's some sort of bookkeeping or what have you. And now they have to change their whole schedule around. Or maybe your bank is merged with another one, and you need the software to be ready to work with this other bank's systems by the time you merge, and you're late, and now the folks in your side of the operation can't work with data drawn from the other bank's IT systems. Very, very adverse. So in terms of asymmetric risk, coming in a month early is often vastly better, sometimes even advantageous compared to coming in a month late. This is an example of asymmetry. And this is a sobering diagram. What is this diagram telling us? I would say on the lower axis here, we have the target completion date in days, and on the y-axis with the actual completion date in days. This is a scatter plot for an actual software development organization. What is this graph telling you?
No one is ever coming under time. No one is ever early.
Is that sobering or what? Okay, so that's one thing it tells you. Why do we say that? Why do we say that? Where would a project be located? One of these. It would be below the what line? The 45-degree line here, right? This diagonal line, right? The target completion date. The target completion date will be greater than the actual completion date. Okay, so that's one thing. What other things do you see in this pattern, in this diagram?
There's some way, like look at that one. That one says it would take 4 days. It actually took 260 days.
Okay.
Someone went on a really long holiday. Said, yeah, we're going to finish this in a week. Like 6 months later. Interestingly enough, there's one ones that they would say would be done immediately, and it took many days.
Yeah.
Like, I want to take a spike. Yeah, this will be done tomorrow. Then 2 months later.
Yeah. No, do you think that's, I mean, taking off your professional pride and so on, do you think that's possible? Could you imagine, like...
I would never estimate something that's a 2-month task to be now. Like, wouldn't you just do a spike prototype? You estimate these things?
Okay.
I think we have to be careful here because what we're kind of assuming is that these people are crazy. No. These people are probably normal like us.
Okay, so what might explain this?
I think there's government. It's a government.
Because if the actual 45 one was 100 higher, it'd be much nicer.
Yeah.
I think the problem with this graph, though, is it's not showing what other confounding variables came in.
That's right.
Like one of these projects could have suddenly half the people went off sick or something, and it's not giving us that information.
That's right. Although I will tell you there's a confluence of things, some of which have been mentioned, that lie behind this. One of them is the issue of management. Management saying, okay, we need this done in the next month, right? When are you going to get this done? And you say, well, you know, it's going to take 45 days. No, that's not acceptable. It's not acceptable. It has to be done by the end of the month. When is it going to be done? Well, you know, I think we could do maybe in 40 days. No, you know, your butt's on the line. You're going to be out here on the street unless you finish this. It's going to be done in 30 days, okay? Okay. Yeah. It happens.
Are you sure those bugs won't take a day?
That's right.
They're definitely going to will not. They're going to take a day. No, they aren't.
Yeah, that's right. There is a lot of duress that can be expressed by people with a lot of power, but there's also some other matters here. What thing could lead something that you think will take 2 weeks to take 4 months? By the way, I've seen this before in projects. I've lived through projects like that. Okay, so yes, you're assuming that you have access to the Oracle server immediately, but it turns out that you have to go through a long approval process, and you actually don't have access to that resource immediately. So certain processes are not in place, certain resources are not in place. How about another thing, though?
What about scope creep?
Okay, yeah. So the person who commissions the project says, "Oh, by the way, our business processes have changed since before you got your requirements, since when you got the requirements, and we really need this. It really can't work that way." Or the person who talked with you and gave you those requirements was off base. He didn't know what he was talking about, this aspect of the system. Really, what's needed is something more sophisticated. He just never used that part of the system, and so you've got to fold that in. That can happen. I've seen companies go under because of that, because of scope creep, and it's a vicious cycle. It's late because of scope creep. You're working on things, and because it's late, guess what happens? They give you more requests. They say, "Oh, come on, you're dragging this out. You folks have been working on this forever. Well, guess what? Our business has changed, or we need this extra thing. I mean, you still haven't delivered this project. Come on, you can do this one more thing." That happens a lot. And again, I've seen companies fail because of it. I've seen companies fail because of incorrect estimates. How about other something else, though?
Could be dependencies between those dots.
Could be dependent. That's true. So these are not independent dots. One project depended on another project that was late. Good. I like that. And that gets to the issue of prerequisites, requirements of this project. And in general, folks, it has 4 words. It's the name of a popular children's game. Actually, it's not just for children. It begins with an R. It ends with a K. Risk. Risks. Risk can cause it. What sort of risk will cause this? I heard one earlier. People getting sick. People resigning. Not commenting their code before they resign. Maybe they resign because the project's late, and because their manager is hounding them, and because morale is shot, and because the code they're dealing with is crufty, and no one has time to do Q&A, and no one has time to do peer reviews, and they're fighting with this ugly code base, and they've got better job options elsewhere, so they leave, and it's a vicious cycle. Yeah.
You totally expect someone to be compatible with something, but you can figure out it's not.
Totally. So I'll tell you one. Have any of you folks heard a project called Crystal Reports? It's a product. Okay, it was extremely popular in its time. It was a reporting engine. It's a reporting engine to do sort of statistical reports on data. And you have to be very cautious in software when you buy into third-party projects, because no, it's not like Crystal Pepsi. It's rather different. But it can also cause unpleasant gastrointestinal symptoms. So in this particular case, what it seemed to promise, based on what you could read about it online, based on the marketees that was available, was that it would fit the job. It would allow you to deliver on all the needs. And once you actually get into it, once you fight with it, and once you work with it, you found that it doesn't work with this version of Oracle that you're working with. It doesn't work with this current version of Java that you're working with. And you end up saying, well, okay, let's switch to versions of Java. And then that ends up breaking this library. And then you've got to go see if you can find a replacement for that. And have you ever gotten in a situation where it's like, you had to upgrade your operating system because you need to upgrade an application, and that led to a problem with the libraries for this other thing, and then you upgrade your operating system and it doesn't work with your hardware, and it just turns into this giant nightmare. You thought it would be a 5-minute thing, and it turns into a day. Well, projects can be like that too, especially where you're dealing with third-party deliverables that you haven't worked with before. It's about risk, folks. It's about uncertainty. Do you remember the 2 aspects? things that contribute to risk. It's uncertainty combined with consequences. So it's not just uncertainty in the sense of musing and you don't know which it is, but it's uncertainty that has some impact, some consequence. And unfortunately, there's a lot of things in software of this sort. There's uncertainties that are known, and there's unknown uncertainties, and they can all bite us. And so a lot of these things that are way above this line had major risks that maybe were unidentified before and were certainly not managed well. You'll notice also that this graph belies the suggestion I gave earlier in the sense of not giving point estimates, because this was a date at which it was suggested. Each of these, in principle, could have had a wide range, and one hopes that a range estimate given for one of these projects would have extended well across, well to the right of here. What's another thing, though, that should stand out? So some projects are way out of whack. Is it all projects that are way out of whack for the actual versus the target?
Like, the bigger the project is, the more likely it is to be off the whack. Like, lots of these other ones are off by, a few days.
Okay, but there are some pretty decent. Okay, there's some truth to this. There's some truth to this. You gold-plated a bit. You put in some extra time to polish things, and so you never come in before. You always come in after. I think there's probably some of that. So the average for this, though, 22 days on average for the target. The actual 56 days. It is a sobering graph. It's room for thinking. And there's a lot of stories writ large in this. Boy, could I tell you war stories. And, I talked about the badness, the sort of things. If you come in too early, it's a month early, it's often not so bad. You come in a month late, it's very bad. Okay. Now, the fact is that over the course of a project, the uncertainty associated with estimation shrinks. Why is that? It's less to guess about. Fewer risks that are unexamined now. And in fact, I understand those who were in 370 had some sort of rational unified process that you applied. Is that right? Yeah. Early on, which hopefully have been estimated, factored into range estimates, and then successfully you get more and more certain. But tell me, over the course of this, when do you have the greatest latitude about when do you have the greatest flexibility in terms of changing how quickly you deliver it? It's in the beginning. Why is that? Why do you have the greatest latitude affecting how quickly you deliver it early on? In the beginning. What things are you putting into place then? That's right. Everything is a fair summary of that. So you're putting into place your architecture. You're putting into place your continuous integration. You're putting into place your standards for coding. You're putting into place the standards for assertions, for example. You're putting into place your testing infrastructure. You're putting into place your design. You're choosing your language, Scala, Java, PHP, whether you use Google Play on the server, or whether you're going to be using WebSphere or a PHP-backed backend, and these will make really big differences potentially in how quickly you can deliver. Unfortunately, unless you've worked a lot with those technologies before, the impacts of those are often not clear fully. But the point is that the uncertainties are biggest early on, but your capacity to change things, your leverage is greatest early on as well. Later on, you have more and more uncertainty about how quickly it will finish up, but you also have less and less ability to change it. It's like you're on a bike going downhill, faster and faster speeds. You have less ability to steer, but you have greater and greater clarity what awaits you at the bottom of the slope. My grandfather talked about in the 1930s, 1920s, sledding down a very, very steep hill on one of these flexible flyer sleds. You know those ones with those rails? Yeah. And they were sledding down this steep slope after a major snowfall, and a kid was going down, and a truck came along. It was coming along just in time for the kid to go hit it, and so. But the kid couldn't do anything. I mean, the truck was coming along right just as he was there. He actually went under the truck and through the wheels and out the other side and survived fine. So he was lucky. Not everyone is so lucky. Just remember that. This is a pointy end for good reason. Okay? So, at a concrete level, what are we omitting from our estimates that makes them bad sometimes? Well, there's a lot of things that are sort of not foremost in our mind. They're not sort of the common components of our project that we're forgetting. Give me some examples. What things might we easily omit from a project that could actually take time?
The manifestation of the phrase, the devil is in the details.
In a way, yeah. Yeah, the devil is in the details, because often there's things that will really inflate the schedule that you're glossing over. Give me some of them.
If you're working with new software, you might have time to get used to how it works.
Totally. Get used to how it works, or get used to what its limitations are, or get used to the fact that it ends up not being compatible at all with your other software stack. Could that happen?
Yeah.
Could that happen to smart people?
Yeah.
Darn right. Yeah, you bet it can. It can very easily happen, especially when you've got marketees in the way. You go and you look at a third-party commercial project, and you read about it, and guess who often writes those descriptions? It's the folks involved in marketing, sometimes sales. And they are not often technical folks. We talk about the difference between a marketecture and an architecture. A marketecture is written to sell product, to sort of get it bought, where the architecture is something much, much more concrete. And many a ship of fine software has been wrecked on the shoals of marketectures and marketees. You really often don't know what you're going to get until you bought it. It's as they say in Texas, it's a pig and a poke. You know what a poke is? No, it's not that sort of poke. No. You know what a poke is? P-O-K-E? No, it's a cage. It's like a crate. You can't see the pig. You buy the pig before being able to see it. Maybe all you see is its snout. And then you've got the pig, and maybe it's an emaciated pig. So in any case, or maybe it's a tiny potbelly pig, and you thought it was a 300-pound sow. Okay, so what things are missing from estimates? Some of them here. Okay, how about things associated with ramp-up time for new team members that you've got to bring on? People, when they come on board, they need time to get up to speed on IEPI or on, the basics of the infrastructure, on Scala, right? They need time to get up to speed on how play works. or how Mockito works. They need to get up to speed on the ways in which, Polymer functions. Mentoring of new team members. From whom does mentoring take time? Both the person being mentored and the person mentoring them. And often, who is the person mentoring the new person? It's often the most highly experienced folks. So it's not a bad thing. It's an investment, but it takes time away from the productivity of the most what otherwise would be often the most productive people on the team. And if you ignore that in your estimates, you may be really shortchanging sort of the amount of time it will require. Management coordination meetings, cutover and deployment. Typically in real-world projects, after they are brought to a feature-complete state, after they are deemed worthy of user deployment, there's actually a significant process associated with pushing it out to the user, getting it onto the user's infrastructure, and the cutover process, bringing the users from the old system to the new one, which may involve bringing over data from the old system into the new system. Data that was used in the previous system now needs to be read into the new system. And that can have lots of gotchas associated with it. There's risks. Data conversion things. There can also be issues associated with requirements clarifications. You have to go back to the stakeholder to clarify some requirements. Could you imagine that? Needing to talk to a stakeholder to clarify requirements? Yeah, like an hour ago? Good. That's exactly right. I can imagine it too. These are some items associated with this. Defect correction work. Ladies and gentlemen, one of the biggest risks, the biggest uncertainties associated with our projects is associated with the unknown bugs that lie undiscovered. The bugs that lie undiscovered. They're sitting there awaiting us. They haven't been discovered yet, and a small number of bugs might look good. It could be good. It could be a good sign we have high-quality software, but it could also be a bad sign because we haven't really drained the swamp. We haven't really identified those bugs out there. Lots and lots of stuff. I won't go through these in detail, but suffice it to say, it's very easy in our estimates to omit certain things. Here another set. Vacations, sick days, training, weekends, holidays. I remember one team not so long ago, and it made the mistake, a fateful mistake, I might note, of having a hero. No, I'm not talking about the submarine sandwich, or the, what's called a hero. Some places hoagie, and others submarine sandwich, and other. I'm talking about a hero in the sense of software. And contrary to, who was it, Tina Turner, who sang we don't need another hero? A lot of software teams believe they need a hero. They need the person who stands like a colossus, standing astride the world, and leads the project and drives things forward as kind of the preeminent contributor. And heroes are great as far as their contributions go, but it's vulnerable. Why is it vulnerable?
Because it comes down to one person.
Comes down to, and what could happen to that person? Let us count the things. Give me one. Okay, they can be hit by a bus. You hear software projects elsewhere in Saskatoon talking about their bus number. How many people have to be hit by a bus to immobilize them? And not in the sense of the people hit by the bus, but the project. Immobilize the project, progress of the project. You want to spread things around, raise your bus number so that it's so that you're less vulnerable to these things. What other things could happen to this person? Could be given too much work and burn out. They could be shifted to another project. They could go find a new job. They could get really sick. They could get married. They could go on vacation. They could become incommunicable. They could, in other words, become unavailable. And in this case, several years back, they had the hero who was designing the system and didn't want others to touch their stuff. It's my code. It's not your code. I don't want you as part of it. It's my stuff. I'm maintaining this, and it's good quality stuff. I don't want your greasy kid hands all over it. And so they took very tight control. And guess what? Well, their team won the regionals for the coding competition, and they were called off to the programming contest elsewhere in the continent, and they left town for 3 weeks or something like that. And the project died. It was horrible. It was horrible. No one knew what this code did. They couldn't maintain it. There were bugs in it, and it ended up in a bad state. And meanwhile, this guy was off in the coding contest. Who could have predicted? Well, the project left itself vulnerable to this by buying into the hero, as putting all its eggs in that basket. And that's often the things that can happen. We don't need another hero. I agree with Tina Turner on that one. We don't want to put ourselves out in a vulnerable position with respect to these things. Okay, I'm going to skip through this. Right. Okay. So what I'm going to recommend as far as estimates is that you give actually 3 estimates. A range, yes, best and worst case, but also most likely case. And see if you can give estimates that do, in fact, a large fraction of the time, 95% would be great, include the actual value as measured. Okay. The key approach that I recommend, and that you'll see applied widely within the software industry, is a technique known as decomposition. So here you take a planned deliverable, a planned task, apart into pieces, and you estimate those pieces. Why would you do that? Because, amongst other things, the estimates for those pieces may be off on one side or the other, but often those errors cancel when you add them together. Connor mentioned this notion earlier. You group things. Sometimes there's errors in the positive direction, sometimes in the negative. Often those errors are smaller when you think about concrete things, but they often will cancel out when you add them together. So that's one reason. Another reason is when we think about concrete things, we can be much more specific. Ladies and gentlemen, I don't know how many times I've been faced with thinking about a big task. A big task, it's almost certainly unique. I've never done it before, and I'm asked to give an estimate for it. And if you just think about the task as a whole, it's very hard for us to give a grounded estimate. By grounded, I mean really tied down by empirical understanding. But if you break it into pieces, you start thinking operationally. You start thinking, what do I need to get this piece done? What would I need to do? What steps would I need to take? Is there any way I could do that in less than a few days' time? And you start being much more concrete in terms of thinking through what is needed, and that gives you a better basis for at least a range of possible times. Here we are typically taking apart this overall project into pieces. We have a much greater sense of sort of what's required once we enumerate the different features. So you break this overall deliverable perhaps down into features, and then you give some estimate for each in terms of staff weeks. So sometimes called person weeks. These are, it could be one person over 4 weeks or 4 people over 1 week. And then perhaps you measure the actual estimate, and you could always quantify the number. But we're going to be giving a range estimate. So we're going to be giving not just one number here in this estimated staff weeks to complete. We're going to be giving a best case, a worst case, and a most likely case. Okay. Okay. Now, it turns out that these error bars, or these ranges we're going to give, are almost always too what? Too wide or too narrow? Too narrow. Just like those estimates we gave for the blue whale, right? Right? They were too narrow. We were supposed to have wide enough ranges. 95% of the time, the true answer would fall in there, and it actually fell in there maybe 20% of the time. They were too narrow. 80% of the time, it was outside of them. Okay? The wider it would be, the larger the fraction of time it would be in there. So, we're going to tend to underestimate, and there's ways of correcting for this that I'll allude to. Okay. So the first principle here is avoid point estimates. They hide uncertainty. And often, if they're pressed to give an answer, developers will give something closer to a best case estimate. Why is this psychologically that we tend to err on the side of best case? Give me a couple reasons.
You personally don't want to go on that long. That might bias us a bit.
Yeah. You wouldn't want to go. And also, if in terms of just professional pride, we often err on the side of thinking it's going to take less time. I mean, come on, I'm a pretty good software developer. It's not going to take me that long to write a little utility like that. Surely it's not going to take that long. And moreover, we omit things. We sort of think of the common case, the expected case, the usual case, and we don't tie ourselves up with thinking about conflicting library versions and incompatibility with existing tools or what have you. So point estimates, very, very dangerous. Range estimates make an optimistic assumption, pessimistic, and expected case. Now, thinking this through explicitly, thinking through a pessimistic possible worst case, why could that be useful? Well, one thing is it can communicate how uncertain you are. That's great. But why else is it useful to think through the pessimistic case?
That might come in handy. For example, the Olympic part, your worst case is past the start of the Olympics, no one will pull down the features.
Yeah.
Cut out things so that your worst case coincides with the day before the Olympics, I guess.
Okay, so that's good. Yeah. It may force you to rethink the scope. And another thing is it forces you to think in very concrete terms what might go wrong. Like what things could go wrong here? Where are the risks? I know you folks in your projects have top 10 risks enumerated. They're perhaps not as fulsomely explicated as I would love, but they're a great start. But there's often risks associated with these estimates that lie behind our numbers, and we're forced to think those things through. Often our estimates will include these risks, and over time they'll start to become more and more narrow as time goes on, and we're more and more clear. Okay, so this is an example of a range estimate that I'd love to see from you folks. Boy, would I love to see this. This would be just dynamite stuff, like those test matrices, and I've yet to see a nice diagram of your system showing, the different screens and how you get there and how your tests will map onto that. Please give that to me. I'd love to see that in the next incremental deliverable. Boy, would that be great. Boy, would I love to see a discussion of test cases, and I'd love to see the test code. Man, do I want to see that. I've seen some of it, and a thing of beauty, what I have seen. But I want to see more. I want to see more. Think about really pushing on the test side for ID3. Ponder that. So here we have tests and features of the system. I'd like to see you give a best case, a most likely case, and a worst case here. Sometimes people give an expected case as derived from this. Okay. The most likely case is the mode. It's sort of the peak. Sometimes people distinguish also a mean. The mode might be here. This is the single most likely. Where would the mean lie? To the left or the right of this? Right. To the right of it. Maybe it would lie somewhere out here. So this might be the mean, and this is the mode here. This is the mean of x. The expected value of x. And physicists have other ways of writing these things in their beautiful notation. I think due to Einstein, if I'm not mistaken. The cat and the bra, right? Yeah. What's that? Is it from Dirac? He was an engineer, I think. Yeah, yeah. Yeah, when I was in freshman year, I was taking differential equations, and my professor said, he said, Paul Dirac, he made these great contributions in mathematics, and mathematicians were ashamed because they were given by an engineer. He seemed chagrined by it. In any case, so range estimates often underestimate the width of intervals. So I'm going to go over this. In past years, I would have gone through this in gory detail, but I want to talk about this at a high level and get you familiar with the basic ideas without spending a huge amount of time on it. So basically, for each subtask, remember, you're taking the overall task and you're dividing into subtasks. And you should specify a best case where it's less than 1% chance the actual number will fall below it. A worst case, less than 1% chance will fall above that. And a most likely case that you think. And then an expected case will actually be derived from these others automatically, rather than being explicitly given. And there's some statistical care associated with this that I may touch on in the closing minutes here. Let's, oh, that came out weird. Okay, so one of the issues here, folks, is that it's not appropriate to take these best cases for the subpieces and total them up to a best case for the entire project. Why not? Why can't you just say, okay, best case for each subpiece, we'll total it up, and that will give us a best case for the overall project?
Really, really small. Vanishingly unlikely.
That's right. That's right. And it's one might say vanishingly unlikely that you'll have the same best case for each one in turn. You may get that best case for one, but you probably won't for the next. And as a result, if it's less than 1% likely for a given subtask that you're less than the best case, if you just were to total them up, the chance that the whole project would be less than that best case would be, like 10 to the minus 20th or something. So it'd be far, far, far more conservative. Here, the recommended strategy, and I'll leave it to you to review some of the slides, because the time is running short here, is basically to estimate an expected value, a mean, for each subpiece, and then total up those expected values to get an expected value for each estimate, derive variance for each subpiece as the sum of the variance from the pieces, which does assume independence, and then from that you can derive a best and worst case from the overall as well. So basically, we're going to take these best, worst, and most likely cases. We're going to turn them into two things that we're going to be able to sum up. One of them, the expected value, and the other, the variance. And then, based on those things and totaling them up, we're going to be able to derive values for the entire thing. So I'll give some formulas for this. But if we have here a best case and a worst case, we're going to have a formula for the standard deviation that comes out of that, and a variance, and then we're going to total up these variances into a variance, ladies and gentlemen, for the entire project, and we're going to turn that into a standard deviation through what mechanism? If we have a variance, how do we turn it into a standard deviation? Speak as in one voice. Square root. Square root, yeah. Good. Okay, so here the common statistical assumption is you take the best case, the worst case, and the most likely case, and you combine them according to one of these two formulas. You can use a more conservative formula or less conservative to arrive at an expected value. Okay.